The Cheeky Peak team is proud to introduce you to the Nano-X 250 litre 2V dished brew system. Suited for both small startup breweries or for a pilot brewery, when moving through the design process, we set out specific goals to ensure this system would meet your brewery's needs. These design goals include a 250 litre final batch size, which is both a commercially viable volume for startup breweries and the perfect test volume for large commercial breweries. An affordable entry point for startup breweries to ensure they can build their brewery on a cost-effective budget. An extremely small footprint so your system can fit into the smallest of spaces in your brewery. A system design that reduces your wastage and increases your overall brewhouse efficiency. An intuitive design that allows you to clean and maintain your system in an extremely efficient manner. The inclusion of multiple system components that reduce the need for constant monitoring so you can complete other brewery tasks. A system that integrates mobility so you can easily move and store your system anywhere within your brewery. A specific focus to design a system that requires minimised power consumption so your brewery can produce beer in an energy efficient manner. And finally, a user-friendly system so you can get brewing immediately with easy installation and without the need for complicated functionality. To demonstrate how we achieve these goals, today we're going to take you through a full build overview of the Nano-X 2V dished brew system. Central to the brew system is the 3mm thick 304SS platform which connects the two vessels to create a fully mobile brew system. The heavy-duty caster wheels allow you to move the system with ease around your brewery for use and storage. This central platform is also a dual purpose for housing the brew system pumps. The intuitive design of this pump platform has meant that we have been able to significantly reduce the cost of a brew system that produces 250 litres of wort. Two 1.5-inch triclover bulkheads are installed into the platform which allow both the brew system pumps to attach. Ensure these bulkheads are fixed tightly to the platform using a shifter if required. Each brew pump will come with a triclover pump bracket, which then allows you to simply attach on each pump to the platform with the triclover clamp and seal. This convenient design then allows you to easily remove your pumps for any required maintenance or cleaning. Ensure these pumps are attached on tightly to reduce any movement throughout your brew day. This brew system consists of two vessels in total, a 270 litre dual dished boil and HLT, plus a 270 litre dished mash tun to produce up to 250 litres of wort. This two vessel design ensures your brewing footprint is kept to an absolute minimum. On each vessel, a site-class butterfly valve kit is installed onto the dished bottom. The dished bottom design means volume losses throughout your brewing process are kept to an absolute minimum, improving your overall brewhouse efficiency, which becomes extremely important from a commercial perspective. The other important factor of the dish design is the ability to perform complete clean-in-place operations without the need to pick up the heavy vessels for draining. Simply open the valve and your vessels completely drain, ready for storage. The false bottom design for the dish mash tun is centrally hinged with a retractable handle for easy installation into the mash tun. Included with the mash tun is a 304SS grain chute and front opening door for easy access for disposal of your grain. This major feature significantly reduces the time and labour required for grain removal. Simply open the door and the level access false bottom allows you to remove the grain with ease. The mash recirculation inlet is located at the top left of the dished mash tun. A triclover adapter is installed first. A 304SS shower ball is installed onto the end of the recirculation arm. This shower ball provides a gentle shower over the surface of your grain bed to provide a uniform flow and improve your brewhouse efficiency. The recirculation arm is installed on the inside of the triclover adapter. The intuitive non-fixed design of the shower ball means a CIP ball can quickly be installed ready for your clean-in-place process after brewing. On the mash recirculation inlet, a 304SS flow meter is installed. This flow meter gives the brewer easy control over the flow rate of their mash recirculation, meaning they can precisely dial in their required flow rate. It also gives the brewer an easy access point for quick monitoring of their flow rate away from the system without having to remove the mash tun lid. The same tri-clover inlet adapter is installed onto the dual boil kettle and HLT. Onto this adapter, another flow meter is installed to again control the flow rate returning back to the HLT during the figure 8 mash recirculation process. A simple return elbow is installed onto the inside of the adapter. The intuitive design of the dual flow meters means that we can exactly match the flow during the figure 8 recirculation process and walk away with minimal monitoring. On the dual boil kettle and HLT, a side-class ball valve is installed and is the main point from where you will draw liquid for your mash recirculation, whirlpooling, chilling and transferring process. A whirlpool port is installed to conduct whirlpooling processes and ensure a maximum amount of hops and trub is settled for removal through the dish bottom before your chilling and fermenter transfer begins. This whirlpooling process helps to increase the volume of wort that is transferred into your fermenter. A thermowell is installed into the central triclover port on the dual boil kettle and HLT. This thermowell is dedicated for housing the temperature probe for one of the dual NanoBoss touchscreen controllers. A second thermowell is installed into the back end of the mash tun, which is also dedicated for housing the temperature probe for the second dual NanoBoss controller. On the mash tun, the triclover port located directly out the side is the point where wort is drawn for your mash recirculation process. This location is important as it ensures your grain bed does not suck in and compact to potentially cause a stuck mash. Two triclover elbows are attached at this point to better direct the pump inlet hose in a neat, compact and easy to access manner. A flow control valve is attached to the outlet of the mash tun pump. On the outlet of the flow control valve, the first of the insulated silicon hose is attached and directed across to the inlet of the HLT flow meter. This flow control valve is the point at which you will set the flow rate directed from the mash tun into the HLT. As you can now see, the flow path from the mash tun is directed from the mash tun into the pump inlet, out of the pump outlet where the flow rate is controlled as it enters into the HLT. On the back end of this pump manifold is a dedicated ball lock flush port. After the mash recirculation process is complete, this flush port allows any remaining wort in the lines to be flushed out to further reduce any wort wastage. The same ball lock flush port is also attached to the boil kettle and HLT manifold to again reduce any wastage throughout the remaining brew system lines. Once installed, the pump inlet hose from the HLT and boil kettle is attached from the kettle and into the pump. Directly on the outlet of the pump, a T-piece is installed to house both the dedicated whirlpool valve and the flow control valve. This specific design creates an easy access point when you begin the whirlpool, chilling and transfer process. On the outlet of the flow control valve, the second insulated silicon hose is attached and directed back across to the inlet of the mash tun flow meter. From this view, you can now see the flow path from the HLT is directed into the pump, the flow rate is controlled and continues back into the mash tun to complete the figure 8 mash recirculation process. The secondary whirlpool valve off the pump can then be utilised after the boil to complete whirlpool, chilling and fermenter transfer operations with the use of an inline chiller. After brewing operations are complete, the integrated flush port on the boil kettle can be utilised to flush through any remaining wort from the lines and chiller, further decreasing any wastage throughout your brew day. When designing this brew system, a conscious effort was made to reduce the power required to operate a brew day. By developing a 2-vessel design, It has enabled this system to be heated all from the one vessel, significantly reducing the overall power consumption throughout the brew day. The heating elements are controlled through dual NanoBoss touchscreen controllers. This is the heart of the system to run all your mash, boil and whirlpool operations with an easy to operate touchscreen interface. Mash profile automation is integrated into the control system to reduce the need for constant monitoring and adjustments throughout the mashing process. On top of the automation and easy to use interface, temperature is precisely controlled with the integrated PID heating technology and boil rate management, which further increases the energy efficient manner of the system. To reduce the need for removal of the central recirculation arm when cleaning, a dedicated CIP port is located to the front on each of the vessel lids. This allows for the simple installation of the included CIP spray ball to complete all your cleaning operations in a fast and efficient manner. The CIP spray ball can then be moved into the boil kettle, or the lid from the mash tun can simply be transferred over to the boil kettle to complete all your CIP operations. For more information on the Nano-X 2V dish brew system, please visit us online at cheekypeakbrewery.com.au or email us at info@cheekypeakbrewery.com.au.